Hello my dear students, once again welcome to your online class. So today we will be continuing with the chapter lenses, and in this topic we will be discussing about the sign convention rule, the linear magnification, the power of the lens, simple microscope and some of the application of lenses. Now coming to the sign convention rule, what do we have is any distance that is measured in the direction of the incident ray is considered to be positive, and any distance in the direction opposite to the incident ray is considered to be negative, and any distance above the principal axis is taken to be positive and down the principal axis is taken to be negative. So following this rule, let us see for a convex lens. Suppose if I draw a convex lens, okay, so this is the principal axis, this is the optical center, and any distance is measured from the optical center. So if I have a focus here, I have the second focal length, I have the center of curvature and the center of C1, F1, F2 and C2. So now in case of a convex lens, so let us see what will be the sign of the image distance, the object distance, the size of the image and the size of the object. Now if I keep the image this side, what happens? The incident ray I draw in this direction, and where does the ray go? After refraction, the ray will pass through the focus, okay, and then this will, one passing to the focus after refraction, it will emerge parallel to the principal axis. So the image is formed somewhere between the focus and the center of curvature on the other side. So now if you see the image distance, now the image distance is defined as it is the distance of the image from the optical center to the image, and similarly we have a object distance. So what is the object distance? The object distance is the distance from the optical center to the object. So the object distance is given by u and the image distance is given by v, and we know that the focal length is given by L, okay, L, it is given by F. So now in case of the convex lens, if you see what is the object distance? The object distance, if I measure, it will be in the direction opposite to the direction of the incident ray, because I will be measuring in this direction. So therefore the object distance will be negative. So remember this, in case of a convex lens, the object distance will always be negative. Now coming to the image distance is measured from the optical center to the image. So in this, while measuring this object distance, image distance, we see that we go along the direction of the incident ray. So therefore the image distance is always positive. Now coming to the focal length, when we measure the focal length, we go in the direction of the incident ray. So therefore the focal length is also positive. So now coming to the size of our object and the size of the image. Okay, so we see that the object is above the principal axis. So therefore if you measure the length of the object, it is always taken to be positive, and the length of the image, it is below the principal axis, so it is taken to be negative. Okay, so this is how we provide a sign to the image distance, object distance, the focal length, the size of the object and the size of the image. So now similarly if you take for a convex lens, okay, so in case of a convex lens, okay, so I draw a principal axis, the optical center, focus, center of curvature, focus and the center of curvature, okay, C1, F1, F2 and C2. So if I keep the image somewhere, object somewhere here, if I draw the incident ray passing through the focus, and in this case this will appear as if it is going there. So this will, once that passes on, I will draw the other ray, okay, passing through the optical center, goes without any deviation. So if you extend it backward, I see the image will be formed there. So now in case of a convex lens, so considering the size of the distance of the object, it is opposite to the direction of the incident ray, so it will be negative. Okay, we see the image is also measured in the direction opposite to the incident ray, so that will also be negative. And the focal length here is also measured in the direction opposite to the direction of that of the incident ray, so that will also be negative. And the size of the object and image both are above the principal axis, so both will be positive. Okay, so it's so simple. Okay, so you just have to understand that anything that is measured against the direction of the incident ray is negative and along the direction of the incident ray is positive. Now, the second thing, in the sign convention, we also have a formula known as a lens maker formula. Okay, so the derivation is not in the syllabus. Lens maker formula. So the lens maker formula, it gives us the relation between the object distance, the image distance and the focal length. Okay, so it is given by the formula 1 by V minus 1 by U is equals to 1 by F. Okay, so this is known as the lens maker formula. So what is the lens maker formula? It is the formula that gives us the relationship between the image distance, the object distance and a focal length. So now coming to the second point, what is linear magnification? Okay, so what is a linear magnification? Linear magnification is nothing but just the linear magnification. So it is nothing but it is equals to the ratio of the size of image to the size of object. Okay, so this is known as a linear magnification. So the linear magnification is the ratio of the size of the image to the size of the object. Now coming to the power of the lens. Now there is a difference between a magnification and a power. So what is power? The power of the lens is the reciprocal of focal length taken in meter. So if a lens has a focal length of f meter, okay, so what do you do? So therefore its power will be equals to 1 divided by f, and remember the focus must be in meter, so the unit of the power will be per meter. Okay, and this per meter is also known as dioptry. Okay, so the dioptry is the SI unit of the power of the lens. What is the power of the lens? The power of the lens is the reciprocal of focal length taken in meter. Even if the focal length in the question, if it is provided 20 centimeter, so you will convert it into meter, which will be equals to 20 divided by 100 meter. Okay, so in this way we can convert the centimeter into meter, and whatever is the focal length, the reciprocal of the focal length is defined as the power of the lens. So now coming to the next important topic, that is the simple microscope. Now the microscope, whenever we hear the microscope, we always think it is very complicated. But here in this chapter, what is a microscope? Simple microscope is nothing but it's a convex lens of a very short focal length. And in exam, you will be asked to draw the ray diagram of a simple microscope. So which diagram you will do? You will draw the sixth diagram that we had drawn in case of a convex lens. Okay. So you will simply make a convex lens. Okay, a principal axis, the optical center. I have the F1 here, C1 here, F2 there and C2 there. So when you use that convex lens as a simple microscope, remember that the object must be kept between the focus and the optical center. Okay, so one ray parallel, the another you can draw it passing to the optical center itself. So the one that is parallel, it will pass through the focus. So we see that this ray is a diverging ray. So the image will be formed by extending the refracted ray backward. Okay, and here is the image formed. So clearly in this diagram, we see that the object is magnified. Okay, so thus we can say that this is a simple microscope. So a simple convex lens of a very short focal length is known as a simple microscope. And when we want to use this convex lens as a simple microscope, we must keep in mind that the object must be kept between a focus and an optical center. Now coming to the last topic, the application of lenses. So we know that many of us, we wear glasses in our eyes due to the sudden sickness of our eye. So the first uses of the lenses is, it is used to correct the eye sickness. It's used in binoculars, it's used in telescope. It's also used in mobile phones and as well as in the cameras. Okay, so you may learn many or few of the uses from your textbook. Okay, so this is the end of the chapter, lens. It's very simple and easy to understand. You may go through my complete video which will help you to understand the chapter in a more better way. And if you have any problem, you are free to ask me. And also at the end of this video, I'll send you a link that will provide you the solution of the questions of the exercise. And yes, you are always free to ask me any of the queries regarding the chapter. Thank you.